Okay, so hello everyone. Welcome to Madara Community Call number 7. Today we have a pretty packed agenda. So let's go over the item of the agenda. Yes. Okay. Can you see my screen? Yes. Okay. Cool. So basically, we'll start with a presentation of Starknet by Lucas, because we realized that there are many people that are new to Starknet and not familiar with some concepts. So we should not assume that people contributing to Madara are already familiar with Starknet concepts. So it will be good to have this presentation by the amazing Lucas to have better view of some important concepts of Starknet that you need to know in order to contribute to Madara. Then we'll talk a bit about Sharingan Testnet, an update about the learnings about the testnet, the future plan for the testnet, etc. Then Clément will do a deep dive into the testing architecture of Madara and the improvements plan, what we want to improve and what not. Then Greg will do a presentation about the testing campaign plan for Sharingan Testnet. Then there will be a presentation by Ben on the proving and data availability, because obviously we want that for Madara. In order to have real use cases, we need the proving side. So we'll discuss about the current thinking. Obviously, nothing is set in stone, and we encourage everyone to participate in those discussions. But this is just to kickstart the discussion around the proving. And then Mr. Oak will do a presentation about creating Madara nodes from out of thin air. So it will be about DevOps related stuff, infrastructure stuff, best practices and whatnot. So it can be very interesting if you want to participate to the testnet, etc. So yeah, this is the plan. Okay. And okay, so let's start by the presentation of Starknet by Mr. Lucas. Mr. Lucas?
Yeah, let me get my slide.
What a joke.
Okay. Okay, so are you all seeing my screen? Yes, okay. So let's go here and let's start with the most important notion. It's account abstraction in Starknet. So in Ethereum and most of blockchains and Polkadot, you have an EOA, which means that you have a private key that controls a public key. In Starknet, you have no notion of public key, private key, or accounts. Everything is a smart contract. So you have a smart contract account that needs to define an API that is written here. So here is for invoke transactions. You need to have a validate entry point and an execute entry point. The validate entry point is here to validate a transaction. And this function will tell the protocol what is a valid transaction and what is not regarding the smart contract account. So in Ethereum, validate is the signature. So when you send a transaction to a node, it verifies the signature and says, okay, this is a valid transaction. I can try to execute it. Maybe it will revert, but at least the person sending this transaction is the person controlling the private key. In Starknet, as we don't have private key, we need to differentiate a transaction that will revert because there's a problem in the execution and an invalid transaction. For example, if we didn't have the validate entry point and we just had the executes, I could send a lot of failing transactions through Abdel's accounts and drain all the ETH with the fees. So that's why we need a validate entry point. We also have these for deploy account contract. So we have 3 transactions. We have deploy account, declare, and invoke. So we have validate declare, validate deploy, and validate invoke.
Maybe you can talk about what is each type of transaction.
Yes, right after that.
Oh, okay, sorry.
Before that, we had complete account abstractions, a complete account abstraction, which means that we didn't have the nonce in the protocol. And as we were not sure how clients would handle replay transactions. So before we had the nonce in the validate API. So for validate, you had to send the nonce as call data. It wasn't in the protocol. So it means that if an account contract didn't check a nonce or didn't have a replay attack protection, someone could like create an account contract and just verify the signature without any nonce. And you could take the transaction from 6 months ago and send it again and replay it. So to avoid that, we added the nonce in the protocol. All right, transactions. Do we have something here? Yeah. So we have 3 types of transaction: invoke transaction, declare transaction, and deploy account transaction. So at the genesis of Starknet, there is nothing, but we'll have to have an account contract because, okay. To declare something, you need to go through an account contract. To invoke something, you need to go through an account contract. And to deploy, you can do it without an account contract. So if you have a plain Starknet, like empty Starknet, you have to declare a class hash to deploy an account contract. But you have nothing to declare it because you have to go through an account contract. So you need to either feed an account in the Genesis block or an already declared class hash. Otherwise, you have a circular dependency and you can't do anything. But
I think you need to explain what is a class hash and the particularity of.
Yeah. But the idea here is that this transaction will deploy an account contract and charge a fees after it has been deployed on the same address. So as you would need to transfer ETH to your public key in Ethereum before doing any transaction, here you would need to send ETH to your address before deploying your account. So you can pre-compute the address of the contract. So you have your address, you send ETH there, and you send a deploy account transaction, and it will deploy an account and consume the ETH that you sent on this address. So contracts. In Starknet, we have a mechanism to avoid the duplication of bytecode. So in Ethereum, each contract is something that is deployed on the blockchain. And even if you deploy 10 times the same contract with just the constructor arguments that change, you have 10 different smart contracts. In Starknet, for example, if you have an ERC20, so in Starknet, smart contract works as PO, like OP, or whatever. Each smart contract is a class, and you can instantiate an instance of this class. So for example, if I take the Open Zeppelin ERC20, I declare it, and then I deploy it with my arguments, and Abdel wants to do the same. He can deploy the same contract with different arguments. So we don't store like 10 millions of contracts. We store the class and the class hash to be able to deploy it easily. And then we're good to go and deploy like millions of instances of it. Does that make sense? I guess yes. Okay.
Sorry, a quick question. So this is not to store the same bytecode
Okay, I'm
many
trying
times,
to,
right?
I created a lightning invoice. I'm trying to pay a lightning invoice.
What?
Sorry, this is not to store like the same bytecode many times, right?
Yes.
Yeah.
Yeah, so you just store the class. So someone will declare it. So he will send like the compiled program, send it to the sequencer, the sequencer will compute the class hash, and it will store in a mapping from class hash to class. And then when you deploy your when you want to deploy a contract, you will say, I want to deploy this class hash. And when you invoke, like when you use that contract, the sequencer will go in the hash table. It will look for the class hash, then load the class and execute the bytecode.
Thank you.
Okay. So now on the block, so Substrate defines their block structure. We define our own. Somehow we don't have a block body in the doc, but we store transactions and everything. Don't worry. So this is the block structure we use in Starknet. How do I go back? Yes. So parent block hash is the hash of the parent block. Block number is the block number. Global state root is the state root of Starknet. We'll see right after how it's computed. Sequencer address is the address of the sequencer that proposes the block. Block timestamp is the timestamp of the beginning of the block. Transaction count is the number of transaction. Transaction commitment is the Merkle root of the transactions. So you have all the transactions of your block. You create a Merkle Patricia tree from it. You get the root and you add it in the block header. Event count, number of events. Event commitments, same as transactions, but for events. Protocol version is the version of the protocol, and extra data is in case we have an upgrade where we need to add some data. We have this field. So the Starknet state. So the state root of Starknet is the Merkle root of the Merkle Patricia tree from Starknet. And so how it works is you have each smart contract has a Merkle Patricia tree with its storage. So if you have different state variables, you create a Merkle Patricia tree with that, and you get the Merkle root of that. And this is the value of the node of this contract in the Starknet state tree. So the Starknet state tree is a Merkle tree of Merkle trees. It's not really intuitive, but it's heavy in computation. That's why we were like delaying the integration, and it's a bit hard to implement. But that's the idea of the Starknet state. We also added the nonce because we have the nonce in the protocol, but once we set back nonce abstraction, this will disappear from the state root. I think there was something interesting. Yeah, the transaction lifecycle. So we have different stages. So not received. So all this will be changed soon, but I guess it's important to understand how it works, to understand the specs. So not received it means that the sequencer didn't receive your transaction. Maybe you didn't send it. Maybe it has been dropped. Received, it means that the sequencer has received it and it's waiting to be processed. Pending is the transaction has been processed. It has been included in the block, but the block isn't mined yet. So this state is confusing and will disappear soon because soon we'll have fast enough blocks, so this will be useless. For the story, we added this because we had blocks that lasted like 2 hours before being mined at like the very beginning of Starknet. Now we're closer to a few minutes, I think, so it's fine to only wait for accepted on L2. Accepted on L2, it means that your transaction is in a block that has been mined. Accepted on L1, it means that the block has been proven on L1, and rejected, it means that your transaction has been rejected and that it has not been included in the block because we don't include yet a rejected transaction. Any questions so far? maybe it's not that understandable. To get the transaction status, do we need to query the sequencer full node? Oh, great question. So to get the best feedback, you need to query the sequencer, but we'll deprecate the sequencer API, so you need to query a full node. But the full
Lucas,
Yep.
there are some questions. I will take some if you don't mind. Okay. To get the transaction status, do we need to query the sequencer or full node?
I was answering that one.
Ah, sorry. Okay. You saw the question in the chat, or it was by
Yeah,
mistake?
no. I saw the question.
Ah, okay. Sorry. Please.
Yeah. So as I said, full node because sequencer will be deprecated. But I don't think they handle rejected transaction. Maybe they do.
I think you are confusing people even more because you said sequencer will disappear. No, the API gateway, yes, but not the
Yes,
sequencer.
but the API, no, the sequencer API will disappear.
Yeah.
But if we query the full node, how can we determine whether the TX was accepted? And so either your transaction has been mined and the full node has it in its state, either he just forwards the query to the sequencer. But
because this is a centralized architecture for now,
yes.
just to be precise.
Yes, and full node don't execute anything. So if you want to have the real state, you need to ask the sequencer. But short answer is use the full node. Are there any plans to fix the number of ticks in a block or the block time in Starknet? What do you mean the number of ticks in a block?
Elias?
I was answering by text, but I can talk. It's just that we noticed that block time on Starknet is not fixed. So I wonder what is fixed, like why some blocks are like 2 minutes long and some are 30 seconds long.
Okay, so a block in Starknet, yeah, we can see that. Is bound. So Cairo, when it's executed, it consumes steps, not gas. So a block is bounded by the number of steps. For example, right now it's 8 million steps per block. So if you have a transaction that has 8 million steps, it will be really fast to process by the sequencer and the block will be really short. Also, there is another notion which is built-in. A built-in is almost a new opcode. It's like a super optimized instruction. So for example, we have the Pedersen hash built-in. If we had to implement Pedersen in Cairo, it will be really expensive. I don't know the cost, maybe 100,000 steps. Whereas at a built-in, it costs not so much, and I have no clue where it's written, but it costs, yeah, it's here. Pedersen is like 0.32 gas, and a step is 0.01 gas. So this is like this built-in is really optimized, and in each block you can fit only a certain amount of built-ins. This is the static layout. So for example, we define that in a block we can put like 100 Pedersen, 100 Poseidon, 2 range check, and blah 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 for each one. So if there is a transaction that does the 100 Pedersen, we have to close the block. So that's why the blocks are not.
So is this because currently one leaf of the recursive Stark proof tree is 1 block, and you fill 1 layout per block?
I'm not sure 1 leaf is 1 block, maybe.
Someone said that it doesn't have to be 1 leaf equals 1 block.
Yeah, it's a number of, I think that a leaf is a train, no, or something. And so you have to fill the number of steps or in order to create a leaf. But the main idea is that if we reach a certain limit for built-in or a certain limit of steps, we have to close the block.
But why?
because we have a fixed layout for now, and we can only prove up to that many and that number of PLCs.
But then that must mean that one leaf is one block, no?
Not really.
Okay. But if one layout is one proof and you can't go above this number of steps, or
Well, okay, let's say I have a block that has 100 Peterson. Let's say I have a layout only for Peterson and Poseidon.
Mhm.
I have one block that includes 100 Peterson and zero Poseidon. And there's only one step in this block. So I have one block that reaches the limit of Peterson. And then the next block is one step also and 100 Poseidon. Then I can combine the two blocks in the same leaf. I respect the layout and the step limits, and I can create a leaf.
okay, I see. So
Not
you're
sure
saying
that's
this
how
could
it
be
works.
done, it's not done like this, but it could be done like this in the future.
I don't know how it's done,
Okay.
but this may be one possibility.
Okay, I see. Thanks.
Uh,
There are more questions, Lucas.
Yeah.
Are built-ins like EVM precompiled? Kind of, yeah. You can see them as
yeah, kind of,
precompiled, kind of, yes.
but harder to implement.
Yeah, harder to implement, yeah. Actually, a precompile is not easy to implement in the sense that benchmarking the cost of a precompile is a nightmare. You need to be very cautious when you design the cost of a precompile because it depends on the hardware, etc. So it's not easy. I mean, yeah, the implementation itself of the logic, yeah, is easy. Yeah, it's true. There was a question, but Ben answered. Okay, and then is this limit enforced to have upper limit on the proving time?
I don't know. I don't think so. I don't think so.
Yeah, it's a good question, actually. Not sure, to be honest.
But anyway, this limit will be lifted at some point. Also, what advantage do the full node adds because the sequencer anyway is centralized? Well, that's a good question. Yes. So what's the
I mean, there
advantage?
are some advantages. For example, the sequencer could lie when you query it. Like, for example, if you want to do a swap, the first thing you will want to do is define the slippage tolerance in order to avoid having way less tokens than planned because of the price change. But let's say the first step for the smart contract in the DApp is to query for the price of a token. So if you don't have your phone node, you rely on some data. Unless you are using Virus, for example, which is the light client with storage pools. But let's say you are using a centralized sequencer to get the data, it could lie to you and make you think that the price is different in order for you to accept a higher slippage and then do a sandwich attack and try to do some kind of malicious MEV to extract value from you. So it's a matter of sovereignty. It's always like that. Having a full node is the guarantee of being sovereign for the data. There are some trade-offs, and like client like Virus that uses storage proofs are a good mitigation because you don't have to have the full state, etc. It's fast and light, but still you can verify the data that you query. But yeah, it's a matter of sovereignty, to make it short.
Yes. Okay. Now the L1, L2 messaging. I think it's a good thing. So Starknet is a rollup on Ethereum, and it can communicate with Ethereum. So you can send messages from Ethereum to Starknet and from Starknet to Ethereum. We have some graphs, which Abdel and Ben love, but I think they're really confusing. So sending a message from L2 to L1. Maybe I should do the syscalls before. Yeah, I should do the syscalls before. Yes. So Cairo is a Turing complete language, but there are some stuff that you can do. For example, IO or communicate with the outside world. So for that, we have syscalls. So syscall is a system call, which is handled by the sequencer. So you have a syscall get block number. It will be, so it's a Cairo function that has a hint in that. And I should talk about hints, but that has a hint in that. That is called a syscall handler get block number, and it's a Python function that will get the block number. And now that I talked about hints, I need to explain what they are, but they are not in that documentation. Documentation. Yes. And we don't have the
Yeah, of course, syscalls can be proven, otherwise the protocol would not be sound. There is a question about are syscalls proven? Yes, but you cannot prove obviously the hints. Yes, because it acts as a black box oracle, but you can prove the computation over those data. Yeah.
So we don't have any documentation on hints, but
you can give the general idea of hints.
I
Yeah.
got you. Let's go there. Let's go somewhere here. And of course, there's no hint. Okay, there are hints. So this is Cairo 0, Cairo assembly, whatever you want to call it. And in Cairo 0, what you could do is have plain Cairo, which is here. And then between those, you could have Python code. So this Python code could be whatever you want. So if you want to make an API call or whatever, you could have everything. But this is only for Cairo, like regular Cairo, not Cairo for Starknet. In Cairo for Starknet, you had to use whitelisted hints, because otherwise you could like destroy the system if you could run like arbitrary Python code. But the hint is a part in the Cairo program that is not part of the trace. So if you have a really expensive thing to do that's easily checked, for example, the square root, you can compute it here. Then you set it, you save it in a variable. Like here, it's saved in this variable. And then here you check that the value is good. So you do output times output equals the X. And then the prover cannot cheat because you have an assert. So it has to comply with the assert, otherwise it fails and it cannot prove anything. So the hint can be seen as an input. So an input, so for example, a hint, you could have the Python instruction like input, which would require someone to type something in there. So you have no clue what's going to be put in there. So you need to check, absolutely check what's given there. Otherwise, you can cheat. So for example, if you want to accept a transaction only if it's the square root, if you know the square root of a number, the sequencer could put like could cheat here and break your contract. But hints disappeared. Now, like you can't access them from the outside. But that's
yeah, there is a good question. Sorry to interrupt you. There are many good questions actually. Would we be able to do it in Cairo 1, not on the public Starknet? Why is that? I will let Lucas explain it when he will talk about Sierra. But TLDR is that we cannot allow arbitrary hints because otherwise we would not be able to prove all transactions. And the whole purpose of Cairo 1, one of the main goals is to be able to prove any transaction. So this was the first question. So yes, indeed, what Lucas meant is that you can access data from everywhere as a black box oracle, but you can query through an HTTP API or whatever. Question, Madara plan to do it as a shared sequencer. And if then full node can give some benefits, and we cannot do with light node for Madara to get same results. I'm not sure I fully understand the question, but shared
I answered that
sequencer.
one in the chat.
Ah, you answer. Okay, sorry. But can you say it here as well for everyone to?
Yeah. So I mean, as a sequencer, eventually there's going to be some type of incentive structure for a sequencer, right? And so if you as a sequencer, it's not the same network operator role as a full node. And they need to be separated out for the network to be healthy. So let's say you are just a user who wants to be operating with the network, but don't want to be a sequencer, let's say because you don't have the capital necessary in a proof of stake context, then you want to run a full node, and that way you can operate on the network completely trustlessly, verifying all the information. Light nodes are gonna offer the same thing, but they do offer a few trade-offs, and the spec for them is not as defined as a full node.
Okay, thanks. Okay, there is another question. So to query an HTTP API, there will need to be a syscall for it, right? Because Cairo 1 cannot perform I/O. Yes, we will need a special built-in that will enable to do arbitrary execution, but it won't be enabled on the public Starknet, to be clear. But we want to support it for other use cases because we want Cairo to be usable not only on the public Starknet, but for example, if you want to do probable computation, but not on Starknet, for example, ZeroSync project, which is using Cairo to prove the Bitcoin chain. So they are not on the public Starknet. So for them, we could enable that in Cairo 1, an unsafe or God mode in Cairo 1 that will enable this. Same for Herodotus, for example, they will need this kind of powerful computation, but they would not be able to do it on the public Starknet for the reason we mentioned about proving, being able to prove any transaction on the public Starknet. And Lucas will explain why and how.
Yes.
You can go ahead. Yeah.
Yeah, no, I thought that Matthias wanted to say something.
Nice.
Yeah, so syscalls, we have them for...
Yeah, I just wanted to add on the shared sequencer thing that it could be built out of Madara, but just it could take out of Madara. It's not something that I think is being worked on right now, but it would be very interesting, like especially for Dojo, which wants to spin up like a lot of games. Like there is a high incentive to have these shared sequencers for all the Dojo games because you can have sorry for my mic. You can have like atomic transactions in between these games and like a very high composability. So yeah.
Okay, thanks. So yeah, syscalls allow you to have various informations in Starknet. Now Cairo 1.0. So with Cairo 0, as I showed, you had an instruction which is assert, and assert is a real thing. I mean, it checks that so if you have assert 1 equals 2, it's like the solidity require, and it can't prove that 1 equals 2, so it fails. And if a transaction is not provable, we cannot include it in the block. We cannot charge fees for it. So this is a problem in Starknet. So we added Cairo 1.0, and Cairo 1.0 is a complete rewrite of Cairo 0 in Rust with a completely new syntax inspired by Rust. And the real new thing is Sierra, which is a safe intermediate representation. So an intermediate representation is a step in the compilation. So you have Cairo high level, the syntax that you will know now, I guess, which is here. So this is Cairo. This is Cairo 1. You compile that to Sierra, and I don't know if there is Sierra here, but whatever, you compile it to Sierra, which is a safe intermediate representation, which means that everything written in Sierra, you know that it will be provable because of the Sierra to Chasm compiler. It's every Sierra instruction is safe and cannot fail. So even if the transaction fails, we can include it in a block and prove it. So for example, if before you had assert 1 equals 2, now we'll have if 1 equals 2, return true, else return false. And it makes it provable. And yeah, so that's why also we can't have arbitrary hints, is because if it fails in a hint, then you can't prove it, and we don't want that.
And why in the first place we don't want that is because, yeah.
We don't want to get dust. So as I said, if a transaction is unprovable, we can't include it in a block. So you can spam, for example, the mainnet with a bot that has a transaction that fails, which is the case now. There are some bots that send transactions that fail, and they're sending like 80%. So what happens is we process the transaction until it fails, and once it fails, we drop it. But we already processed 50% of the transaction, so the sequencer has done worked, but it's not rewarded. We cannot charge for fees, so it's easy to dust Starknet. With Cairo 1, if the validate pass, we then can charge for fees because we can include a reversing transaction.
Yeah.
Coming back to the messaging. So
I think you can try to take 5 more minutes to finish everything.
Yeah.
If you can, please. Yeah.
Yeah. So L1, L2 messaging. So if you are on Starknet, you can use a syscall called send message to L1. You'll have a receiver, so the address that is allowed to consume the message, and then there is the payload, which is what you want to send. So you send the message to L1. Once your block is proven, then the message is available in the Starknet core contracts here. And the address you specified in your message can consume this message on L1, but you need 2 steps for that. Send the message from L2 to L1, and then consume it later in L1. And the other way around, you can send a message to Starknet. So you have your L1 contract that sends a message in the core contract, and after 10 blocks, we consider the transaction final, and we execute the sequencer execute the message on L2. So that's why we have in the off-chain worker, we're monitoring what's happening there, and we're collecting the events here, and we're trying to consume messages. That's through this mechanism. I think I'll stop here.
Okay, good. Okay, let's go back to the agenda. We'll change a bit the order. So let's talk about the proving and data availability by Ben, the awesome Ben.
You guys see my screen?
Yes.
Cool. This is going to have some diagrams that Lucas is going to hate, so hopefully he left. Yeah, so I'm going to be talking about Madara proving in BA, but I think it made sense to go right after Lucas because we have to understand a little bit more about Starknet in its proving context to understand, where we're going as Madara. So this is kind of a simplification of what Lucas just showed. But it goes over Starknet as it exists today as a platform. So we have clients, these are just CLIs, SDKs, front ends that formulate a transaction. They're also going to sign the transaction, send it to the sequencer. So right now the sequencer is outside of the Madara execution context because it's just the API gateway that we've been talking about. Eventually, this will be on the client side of the Madara node, for us. But this is just the way that the platform works right now. So The Starknet OS written in Cairo is, there was a question earlier of, are the syscalls provable? Well, yes, they have to be. Like Abdel mentioned, they have to be to make us a sound protocol. So we have the Starknet OS that's in this execution context, and your smart contracts. So your smart contracts are executed, and the Cairo code is executed. So what do we do with all of that execution and the execution trace of the Cairo code? We send it to the Sharp, the shared prover. And the shared prover's job is to take all these Cairo jobs, all of these traces, and prove their validity. And because we are a validity rollup, we have a prover and a verifier. The prover sits outside of the blockchain context, and the verifier sits in the blockchain context, being the Stark verifier and Solidity on Ethereum. So, and the shared prover, the reason, and we'll get into it today, it's a shared prover. So it's not only proving Starknet. Right now, it's proving the execution of a bunch of different Cairo jobs, including StarkX. And then obviously we want to open this up to Madara as well. And then you can also just write Cairo code. I think someone asked about, we were talking about hints and why we can't have them in Starknet. Well, you can actually just submit a raw Cairo execution trace to the Sharp, writing raw Cairo, and use hints in that. And Sharp will just prove it. So yeah, you do kind of have to separate Cairo as a context from Starknet. That being said, so Madara and Starknet are going to send these jobs to the shared prover, and the prover's job is just to, we'll get into it, is just to prove these jobs in an efficient way to the verifier on L1. So the other piece of Starknet then is these core contracts on Ethereum L1. They do a whole host of things. One of which is to update the state of the Merkle Patricia tribe, which Lucas got into. The other is to facilitate the messaging that Lucas also got into. But so we have to have these core contracts on Ethereum L1. Okay. So to go over the transaction flow for Starknet, we submit a transaction. The transaction is included and aggregated into a block. A proof is generated and it's submitted, and a state update is written. So when we go over data availability in the use case that we are the canonical sequencer for L2, this is again what it's going to look like. We need to submit a proof of execution of the Starknet state, and then we need to write that state to the core contracts on Ethereum L1. Okay, so to get into Sharp a little deeper, the diagram on the right is what I mentioned. So that's just Cairo code executing its business logic outside of the context of Starknet or the Starknet OS. And again, you can just write Cairo code and send the trace to the shared prover. So as the Sharp proves the Cairo job and the trace to the verifier on Ethereum L1, in order to interact with that proof in some way that's useful to our business logic, we need this fact registry. And the fact registry, I'm just going to read the ones on the left, but I can send out this documentation as well. But hopefully this helps kind of understand exactly what the verifier and the fact registry is on Ethereum L1. So the prover takes your Cairo program's execution trace, proves that it's valid, and sends the proof to the verifier. After verifying the proof, the on-chain verifier writes a fact attesting to the validity of the proof in the fact registry. So there's a fact registry that sits on Ethereum L1 that is pinged for the validity of that Cairo code's execution outside the context of Ethereum. This fact is like a trustless stamp of approval certifying the Cairo program was computed correctly. Okay. We'll get into why that's important for Starknet, but it should be a little bit intuitive at this point why that's important. I'm not monitoring questions, by the way, so maybe Abdel, let me know if some.
Yes. Has Starknet open source Sharp? Not yet. Does Madara send execution traces of transactions in a block to Sharp, or is there a relayer service? So Ben will talk about that.
Correct.
Yeah.
Okay, so this is kind of a different way to look at it. This is the Cairo job. So to get into this whole thing is like a layer cake. You can kind of dig down into all of these concepts for months and months and months, but you do eventually have to black box some of it. But so if we go back up here, why, what does the verifier do? Well, the verifier does a whole host of things within the actual Stark protocol. that is a completely different, conversation about moon math and stuff. So if you are interested in diving into those kind of deep math topics, we do have a boot camp called Basecamp that goes into some of that. But for now, we're just going to black box it a bit. Okay, so how does the Sharp actually handle its work? Well, the Sharp is set up into, because the Sharp isn't specific to one application, it's not specific to Starknet or StarkX or DYDX or Immutable. Its only job is to prove the execution of Cairo traces. So it acts as kind of a train station. The architecture of it is like a train station. You basically have these primitives of jobs. The jobs are made up of Cairo steps. Those can be applicative or recursive jobs. So the question was brought up earlier of, is this a recursive job or is this a leave in the recursion of the recursion tree? From what I know, I believe that the Starknet job is an applicative job, meaning that it's going to fill up a train up. Sharp is going to prove the execution of Starknet. It's not that there's some intermediary that is submitting a Cairo proof to Sharp. That's how I understand it. Correct me if I'm wrong, somebody else, and maybe we can touch back on it later. Okay, so
there are some questions.
Yep.
If we send trace from Madara to Sharp L2 prover, that means that we are using Madara in L3 mode and can use different prover, not only Sharp. So Sharp is agnostic to the layer. It is not aware of L1, L2, etc. As Dan said, it can only prove Cairo jobs, which are regular Cairo programs that are stateless. That means you include everything as an input in the memory. And the prover, Sharp, is capable of proving that and return the proof. But then it's agnostic to layer 2, layer 3, etc. So we could use Sharp and be Madara L2 app chain or Madara L3 app chain, L4, L5, whatever. It will be the same. Could we use a different prover than Sharp? Yes, we could. We are agnostic to the prover on Madara, and once there are other provers, we could use them. But it will need also some kind of, if they are not compatible in terms of format and different proof, we will need to have multiple verifiers. So, for example, an app chain could not use both of them at the same time on the same chain if they are not fully compatible. Otherwise, you will need to have two verifiers, and it will be hard to have the same one state with two different provers. But yeah, you could have one Madara app chain with Sharp, one Madara app chain with Lambda class prover, with another prover, and etc. Okay. What if I use a normal Cairo program and prove it outside of Starknet protocol? So you cannot do that with Sharp for the moment. Sharp is not open to do that. You can use it only through Starknet or StarkX. Because indeed, someone needs to pay the cost. So obviously, you cannot just open it for free.
You can on Gurley.
Yeah, you can on Gurley. Yeah, indeed. Technically, the gas for verification will still be compensated by Starkware for now. Yes, as long as there is only one prover and one entity that does the settlement, yes, the gas will be compensated by Starkware, yeah. From the diagram, it seems like Sharp is sending proof directly to the verifier. Can we tell Sharp to send it to other destinations, other verifier, or other DHS? So actually, it's a simplification. So again, Sharp is not aware of Ethereum and whatnot. So in fact, there is a service in between that does the translation between the sequencer and Sharp, and then the sequencer actually sends the Ethereum transaction to do the settlement on Ethereum. Sharp usage is no matter for using Madara in L2 or L3. Using Cairo means we need to use Sharp to prove it, just to check I understand from the answer. So you could use Cairo with a different prover. In fact, there are many existing provers that you can use, but they will not be compatible with the Stark verifier deployed on Ethereum by us, because it's not the same the same prover in the same format, so they are not compatible. But you can use them as closed loop, meaning you can use an open source prover that also have an open source verifier. But you will need to implement everything on your own, like basically your own infrastructure to do the settlement and whatnot. Hopefully it's clear. Okay, you can go ahead, Ben.
Sounds good. Okay, so the last thing I wanted to point out here. Okay, so yeah, the primitives of Sharp are jobs. Those jobs are applicative or recursive. So recursive proving to speed up the operation cycle of the Sharp. Basically, you know, the job is then proving a proof of a Cairo of execution instead of proving a Cairo execution. We batch jobs into trains. So one of the questions is, I think we've already actually had this today, and Lucas answered it. But when is a train closed? Well, it's either closed at the end of an expiry. So let's say we don't have a train completely full with a trace or Cairo steps. We still need to close that train at some point so that you know, the system has some guarantee that this proof is being written in some timely manner, or a max trace cells. So we have some type of max Cairo steps that fill up the train, and then we close that train, prove it, and then everybody, you know, moves on. Okay, so we went over, if you look back at this, that's 3 in this diagram. So proof is generated and submitted to the Stark verifier on L1. So now we're going to talk about 4. So something then, so we've proved the execution of Starknet to L1, but if we don't have any data availability, we lose one of the main guarantees of a validity rollup, which is that we can always recompute the execution of the rollup from data that's available on Ethereum L1, which is our settlement layer. So without that 4th step, we don't have the ability to do that. So we need some type of state update and to write what storage cells within the Merkle-Patricia trie updated and what did they update to. So one thing we do here, this is from the Solidity core contracts on Ethereum 1. This is the update state function. And when we say that we update our state and call data, you can actually see that that's one of the parameters here. So the program output is being sent in call data, UNT 256s. This will massively take down our costs when we can write this in blob data. That is a conversation for another day, as Cancun hasn't shipped yet on L1. So this is how it operates today. We update the state of Starknet based on a proof of Starknet OS execution. The Starknet OS state transition is valid. So what are the arguments? Program output is the main part of the Starknet OS program output. So this is, again, the Cairo program that is provable. And then the data availability fact. So we're querying that fact registry of the verifier. So an encoding of the on-chain data associated with the program output. And in that way, we know that each one of these state updates, each one of these contract storage keys that has been updated is tied to a fact that sits in a fact registry associated with a verifier. So that is the link that gives us the ability to know that this state update is valid, and that, you know, all of these terms kind of start to mesh together. So now it should make sense why it's a validity rollup. Okay. So these are the 2 jobs that we need to do. In reality, like Abdel said about the interaction with Sharp and verifier, there's actually another service that sits in production today between the sequencer and the Sharp, and it is called the GPS, or the GPS ambassador. And since this is a fairly asynchronous function, right? So we have the Sharp that's handling things in trains and jobs and batches. And we have the execution of Starknet that needs to propagate its blocks in some timely block time. So this GPS ambassador is basically the monitor that sits in between the two, that formats this into a format that Sharp can understand, being that it's agnostic of any of the platforms that are writing to it, but then that also monitors where that job is in its execution on Sharp. So, you know, is this proved yet? Has this been written to Ethereum L1? Because we don't want to write a state update for a fact that doesn't exist on L1. Hopefully that makes sense. So what we're going to do for Madara is we basically need to, because we don't want all of these disparate microservices out there, operated by multiple people. We want this to be part of the protocol of Madara. So we're going to bring that GPS into the context of Madara, and Madara, as we've gone through, it has a runtime and a client. So this GPS ambassador is going to sit on the client side and have two functions: one to format the job in this agnostic way that the Sharp can understand, and the second is to track, where along the Sharp train schedule our job is. Yes, and then the second part is obviously to then write the state up to the state update to Ethereum L1 in this fashion that we just saw. Okay, and I get at the top here it says validity rollup because that's the mode this is. But Madara can open itself up to a lot of different things just based on the nature of kind of the substrate SDK and what the work we've been doing. So we don't have to only operate in a validity rollup manner. Celestia has this graphic, which is pretty nice to show kind of the different options that we can employ. In the Ethereum centric world, what we just showed was this. It's a rollup. So we handle the execution. Ethereum handles the settlement, consensus, and data availability. Now, if we wanted to write, say, things to Celestia, then we would have to handle at Madara's level the execution and settlement, and Celestia handles the consensus and data availability. Or we could become a Celestium, which has been talked about in I believe, the Telegram group. Abdel, is someone working on the Celestium yet?
No, there was Diego from Celestial Labs who proposed a bit of a design, but nothing concrete for the moment. He was waiting for us to think about how we want to implement the data availability. So once we have that, I think we can ask him to contribute, at least to design the architecture. Yeah.
Okay.
And we have someone probably here in the call who is, I think, doing an internship at Polygon Avail, which is Polygon data availability solution, who will be interested in implementing that for Madara as well. And an interesting fact, Polygon Avail is using Substrate for their data availability layer.
I did not know that. Cool.
Yeah.
Yes. Sorry, I just want to interject. Yeah. So I'm co-founder of Avail, and Prabal is also on the call. We actually separated from Polygon 3 months back, and Avail is now an independent project. So it's not part of Polygon. Yeah,
it's even better than
yeah, and we are actually starting to build a Validium, with Avail, using Madara.
Oh, wow, nice, very interesting. Okay, would love to hear more about that. And you said that you are one co-founder of Avail, right?
Yes, that is correct.
Okay, interesting. Would love to catch up and discuss.
Yep.
Awesome.
Thank you.
Awesome. Okay. Oh, this is messier than I wanted it to be, but all right. So we saw on the top left what a validity rollup looks like, and we should understand a bit more about how Madara can facilitate that. So from the previous slide on the top right, so a sovereign rollup then, we don't have to, since we're handling the settlement, we don't have any version of Sharp that we're writing a proof to. So it simplifies the architecture as well as an app chain, because in these two contexts, we're just writing blob data somewhere that we need access to and consensus around. So that's like having a data availability committee or Avail or Celestia, these operators that are going to handle the consensus and the DA for us. And then there's this hybrid model on the bottom left, Validium rollup, which I think was in the previous one too. Yeah, Ethereum centric Validium. So we still keep consensus and settlement on Ethereum, and we still maintain execution at Madara's level, but we have this off-chain blob store with another DA layer. So again, I think these are all less defined. The validity rollup is what's in production today, and we basically just need to take over the sequencer and GPS ambassador. but this is kind of where Madara can go, and it sounds like it's been worked on by people on this call, which is pretty cool. Okay, any questions?
Nice. Thank you, Ben. If there are questions, feel free to ask questions. Let's continue to the agenda. So I realized that it was very important to talk about Starknet actually. So we spent 1 hour talking only about Starknet and not Madara, which is good because it will be more efficient for the future to, for contributors with those concepts. Okay, so the next item in the agenda is me. I'm not the item, but I will present it. An update on Sharingan Testnet. So you might know that we this week have launched the first Madara public testnet, which is called Sharingan. And in this testnet, we have 6 sequencers using a proof of authority network. So we talk about sequencers, full node, etc. So just simply a sequencer produces block and the full node only watches the blocks and make sure that the consensus rules are respected, but it does not produce blocks. So we have 6 block producers in this Sharingan testnet, 2 hosted by us at Starkware, 1 hosted by Cartridge, 1 hosted by Lambda class, 1 by Pragma, and 1 by Kakarot. And everyone can join as a full node. In fact, it's pretty easy. And we have a dev block explorer, which is using obviously Substrate Polkadot.js UI, and you can get the node info. And we, by default, using this URL, you will be connected to Cartridge sequencer. So this one. So thank you, Terence, for this, because everyone can follow the network thanks to that. So you can see there that Terence node is connected to some authority nodes. So in Substrate terminology, you have 2 kind of nodes. You have authority nodes and full. Authority nodes are simply block producers, and full nodes are full nodes. Okay. So the network is progressing well. We realized so that there are many bugs, and it's not actually usable with existing tooling. So you cannot use it to deploy your contracts and play with it easily. So it's obviously a big problem. So we will deploy a new version next week, hopefully. And the idea will be to fix a maximum of bugs to make it usable for real use cases. And then we will communicate to have people playing with it and deploying contracts on this testnet and whatnot, joining as full nodes. The more we test it, the better. One interesting fact is that we tested the finality gadget in action on this testnet. Why is that? Because we started by running two sequencers, the one hosted by Starkware, and only those sequencers. And then after that, 2 hours later, Kakarot started his sequencer, and then 6 hours later, Pragma and whatnot. And for something like 12 hours, we were continuing to produce block without finalizing them, which is very good for liveness. So it shows the importance of separating the block production and the finality of the blocks, because there are some consensus that merge those functions to have instant finality. But the main drawback is that it's bad for liveness, because if you cannot come to consensus, you can finalize, but you cannot also produce blocks. And here with Grandpa, which is the finality gadget from, no, on the contrary, Tendermint would have been an issue, for example, in this case, because of the instant finality. You cannot produce block if you cannot finalize. Where here with Grandpa, we were able to continue producing blocks without finalizing. So just an interesting fact that we tested in action. We produced block for 12 hours without finalizing them. And then once we got 5 on the 6 sequencers, so more than 66% for BFT, Byzantine fault tolerance, we were able to then finalize all the chain. basically. So it was pretty interesting. So next step is to fix the maximum of bugs, make it usable with tooling, etc. So Clément and Greg will talk about testing right after me. But yeah, this will be a big priority for Madara. So we encourage everyone to contribute to this testing effort, which will be very important. And yeah, we will try to update the testnet regularly. And then at some point when we stabilize it, we also want to test important features like actual upgrades without, because I said we will upgrade the network next week, but actually it will be a harder reset. We will wipe the state and restart from scratch. But at some point, we also want to test actual upgrades and including some powerful features of Substrate like forkless upgrades, which enable to upgrade your runtime without doing a hard fork because of the WebAssembly runtime and the fact that you can gossip the code of the runtime onto P2P layer. So that means that you don't have to synchronize and do a hard fork to upgrade. So it will be very cool to test those features in actions. But before that, we need a bit of stabilization to be able to do that. So yeah, that's it for the update on the testnet. So please, everyone, help us to make it stable, and etc. So if you find a bug, please try it, even if it is pretty limited for now, but try it. And if you find any bug, please create an issue and try to submit a PR to fix it. But Greg will talk more about the testing campaign right after. So next, Clément. Clément will talk about the testing architecture of Madara.
Yes, so thanks, Abdel. So this will be quite fast. So the idea is actually because we have realized that there is a difference between having like declare or invoke or function that actually works on I would say Rust test, because we have somehow snapshot an input sometimes, and things that actually works end-to-end for the whole ecosystem, meaning the contracts. I mean, the user normally they have some KR files and then they use Starknet Py or Starknet.js or whatever library or SDK, and then they use the RPC and it should work. So we were somehow missing this part, and this is the direction we'd like to cover right now. So this is just sort of a work in progress, but I would say I cannot share my screen anyway. So I need to quit and go back.
Okay.
Wait. Up.
Yeah, please.
Yes, I'm eating.
Okay, yeah, no worries. So you can tackle the questions meanwhile. Okay, so I saw Ben answer the question. And yeah, do we want to separate the block production to the finality gadget for Madara? We want to be agnostic and let the app chains decide what mechanism they want. Again, because we want maximum modularity and flexibility. So we should not do any assumption on the consensus mechanism used by the app feed.
And like the real finality is when you prove
the
execution.
Yeah, true. Yeah, true. Yeah, when I said finality, it was finality on the L2. Good point. Yeah. Yeah, Clément.
Yes, so we already have in the project something. I mean, we already have like a good start with the test. I don't know if it's too small for people to see it.
It is, yeah.
It is too small. Maybe you can zoom in. And how is it like that?
It's better, yeah.
You can zoom in again. Okay.
Way better. Yeah.
Okay, so we already had like a test RPC here, which are supposed to be say end-to-end testing because we use the Starknet.js library, so it should be somehow ISO to what user could have, ignoring completely Madara, just using the RPC as it is. But actually, we did not compile the file ourselves, so we had some compiled file somewhere. And we have realized that depending on the compiler version, there are maybe some discrepancies in the specs and stuff. So the first step for me has been to add here a Cairo contract folder at the root of the project. So right now I'm using the Python tooling to compile. We may change to something else. It really doesn't matter. The only important things to me was to actually have an SRC folder as we would have in any other project not related to Madara at all. And then from this build, using these artifacts everywhere else in the repository. So the idea is just to make sure that we are able to compile, that we know what we are testing against. So this made us realize, like yesterday, we thought that we had an issue with the head declare entry point, but eventually we realized that this issue was indeed due to a breaking change in the compiler version, and that we were testing only against a file compiled with 0.10.3, and from 0.11 point something, then some numbers change the format. So I think that, and still thinking about this, depending on the support we want to have on the legacy tooling and stuff, maybe we need to benchmark against all the compilers. I don't know. Maybe we should add like compilers version 0.10, 0.11, and like sort of have massive testing against all the possibilities that the end user, the tooling of the end user might be. On the other hand, I don't know how long it will stay like that, because with Cairo 1, I think that it's supposed to change. So anyways, the global idea is that we want to make sure that we master the end-to-end testing, meaning from what the user inputs normally, which is a Cairo file, to the Starknet.js or Starknet SDK, and it should work. So the goal is to test this behavior, and maybe deploying some contract, like deploy script that we could have in any DApp that we could do, like a deploy, set some values, make some mint and stuff, but really from the higher possible level. Yes, so as of today, it's still ongoing work. We have also quite a bunch of hard-coded values in the Rust test. If we go to the create here, I think that, yeah, if we go to the client, RPC, no, where are the tests? I don't remember exactly, but in the constant, not this one. Anyway, we still have quite a lot of hard-coded values. Like if it's not really human readable, so it's a bit difficult to track, but all these values refers to contract deployed somewhere, and they are copy pasted in between the end-to-end test and the Rust test as well. So my goal would be to try to sort of ease all these things to make sure that we start with some Cairo file somewhere, and then it goes up, it goes down until the unit test and the integration test. So if anyone has any suggestion ideas, because I'm quite new to Rust testing as well, Python was familiar with, but this is a bit new, then you can join the effort to hopefully have something that is really robust for everyone to use.
Thank you. Thank you very much.
Like,
so yeah, feel free to join Clément and help on this front. There are many contributions to do here.
Yeah, like to me, something like you pick a random hard-coded values here, and you search for it in the project, and you find it in different places. Then maybe a sign that there are some implicit values that are used in different places because it should work, but then it's a bit difficult to move with this. So the goal is not to have this anymore, say, first.
Yeah, okay, makes sense. Yeah, thank you, Clément. And next is Greg, and then Oak for the DevOps infra presentation. But first, Greg.
Yeah, hi everyone. I'll try to keep it not too long since we're running already overtime. So
you can take your time. I was planning 1 hour and a half or 2 hours, so no worries. If people want to drop, it's fine. We have the Zoom, the recording in any case, so take your time. Yeah.
Okay, cool. So I'll just present the test plan that we want to set up for Madara to kind of just increase the current test coverage we have, but also to insert better test practices inside of our current of the project. So one of the first goals would be to actually augment the current coverage, the current Rust coverage we have. Right now, a lot of the tests we're doing are end-to-end testing in TypeScript, which just interact with Madara via the RPC. So it's not even difficult. It's almost impossible to write just unit tests of your function via your end-to-end test. So the solution would be to adopt the method which Abdel has talked already about, so KISS and SRP, which allows us to split the code base into smaller sections, which we can then just unit test in our Rust code. So I will make some issues trying to locate in the current code base what is, first of all, not tested, not unit tested. Also the functions which are too big and which can easily be split in different responsibilities. I'll make some issues for this, and then people can just come pick them up and slowly increase the current coverage we have. So that's the first part. Second part would also be to once we've gotten all that coverage, we want to avoid to actually lose it, which causes a lot of issues if we're adding new code and we start adding breaking changes. Just having a lot more coverage, which allows us to debug a lot faster where we actually included this breaking change. So first, I propose to include a section in issues which describe how the author expects this issue to be tested. This will make the redaction of issues a bit longer for the author, but it also makes it easier for reviewers, makes it also easier for anyone picking up the issue. So yeah, that's the first solution. And then we also want to aim for 80% test coverage of any code added to the code base. So for that, we have the CI running. And I think we should avoid merging anything into main that hasn't at least got those 80% coverage. And lastly, usability testing. So right now we're still in development phase, so we don't really have real users on the testnet. And it's actually those users that allow you to pick up bugs on edge cases which you have never thought about. So for this, we're launching a bug bounty campaign. So we want to incentive users to come and, well, maybe more developers at this stage, to come and try to deploy applications on Madara, which can lead us to discovering bugs. So you will be rewarded starting today if you're able to show us, to expose a bug that you encountered while deploying or interacting with the Madara testnet. I linked here in the slides, I'll share it in Telegram, a starter pack which was made by Glim to actually launch your node. So that it's explained how to launch it, how to interact with it, so you can just try to deploy any Starknet D app written in Cairo on it and just play with it and try to break it. And yeah, that's it basically.
Okay, thank you very much. So stay tuned for the bug bounty program and also for good first issues that Greg will create. So yeah, your help will be very useful for this. So yeah. Yes.
I mean, all of this is great, but I think the main problem behind the test coverage is we have both Rust test and TypeScript test, and the TypeScript tests are not reflected in the test coverage.
Yeah,
right?
yeah, exactly.
So,
yeah.
I don't have felt the solution for that, or yeah, but it could be. I mean, it's very hard to put in place. I don't know if like Kakarot guys, you have already thought about this, Kakarot, or yeah.
Okay, we need to think about it. Yeah, it's not clear, but Clément is thinking about yeah, unifying the testing framework. But yeah, it won't be easy.
wouldn't
Yeah.
even make sense to use a Starknet RS to do this, or
Yeah, I think Clément might be considering using Starknet. I think he's trying to do some stuff on Katana as well. Yeah.
I have started to try using Starkly. Was not sure exactly how to use it. The Starkly book is a ongoing process with actually no documentation at all. So maybe it's also a good issue for people that want to contribute to do something. And yes, possibly using Starkly. We'll see to stay in Rust and maybe yes, nothing to say more.
Okay, thank you. And last but not least, Oak will talk about the magic of spinning out Madara nodes from thin air.
Yeah. Nice to meet you all. This is my first time in a community call, so first time here.
Yeah, by the way, first time I forgot that it was your first time. Warm welcome, man, and I was so happy when Federico announced that you are joining Lambda class. So I'm so happy, and I was even more happy when he said that you will work full time on Madara. So yeah, double happy.
It was awesome.
Welcome,
it was awesome.
Welcome.
Thank you so much. So now I think this presentation is going to be a bit short, but it's probably going to take some time because since I'm doing a demo and this takes some time, it probably is going to take a bit of time. So this presentation is basically the efforts of what I've been doing the last week or so. But first I need to have give permissions for screen recording. 1 second. I have to exit and rejoin.
Yeah, sure. Yeah, please do. You had a question, Matthias, about evolution. Does Lucas answer your question? Or is it?
It's a more complicated subject, but it's basically. So I'm talking about evolution. My mic is horrible. Okay.
Oh yeah. You can see my pain looking at my face, right?
Yeah, I can.
Okay. No worries, we can discuss think about that. Yeah. Okay.
I'm back.
Yeah.
I'm back. So are you seeing my screen?
Yes, we can see. Yeah.
Okay, awesome. So first I'm actually start running the scripts. And then I'll explain it to you what is happening here actually. So in the info folder, we have one script in the Terraform folder, which is run. And basically, you need to pass which clouds do you want, but right now it's only AWS available. And what this actually does is it runs some formulas that we programmed here, and it will deploy some instances in your AWS account. So for that, now it's starting to launch everything. But for that, you need to have some configuration files. You mainly are going to interact with two files, the AWS TF vars, which defines the variables. Probably you want to adjust the node count for you. Right now I'm running 3 nodes, but maybe you just want to run 1. And the other one is the creds TF vars. This is an example one. You just need to copy your AWS access keys and put it here. And after that, you can just run the script and it will work out of the box in theory. I already tested this with Elias and it worked for him. So I'm pretty confident that will work for most of the people. So right now the Terraform script, it's launching. It's already finished. So right now we have 3 instances in AWS for running stuff. Actually, not. We can check the IPs of those also here. We can check the IPs. We can actually SSH into them. But another thing that we've been doing the last week was doing the SL scripts to deploy everything automatically. Right now, the SL scripts only work for 3 nodes because it's hard coded, but in the future we are going to improve this to also adjust according with the node counts that we have in Terraform. I can launch it also. And so basically, I already also did the run script. It's going to fetch these nodes that I listed here, and it's going to use these certificates that was also generated by Terraform to access them, and then execute some installation for the Madara service there. And it's going to build the latest version of Madara and then launching it as a service. So I can run it and then we can check the nodes. The thing about the Ansible one is this is pretty slow to run because of the whole process of building. It's pretty slow, but in the future we can actually pre-compile some binaries because we don't want to use the latest version and just run those. And yeah, so I'm just leaving this running now. And another cool stuff that's happened during this week, actually in the last couple of days, is that we had some shortcut for some default configurations for it to be easy to run a full node on Madara. So right now we can just go to the target for our compilation of Madara, and if you are compiling in the main branch, you can actually use a flag which is testnet, and specifying which testnet you want. Which the only one that we have is Sharingan, and just running this, we can run a full node. So in theory, I think it's going to work. Let's see. No, it's showing some errors. I don't know why.
Yeah,
some clue?
No, it's normal because it's not the same runtime because we did some modification since the deployment of the testnet.
Oh, okay.
And in the clean spec, you have the code of the runtime, and it does not match. So it cannot connect to the same network because it's not with the same runtime code. Yeah.
So the peer IDs changes?
No, it's not. It's not because of the PRID. It's because of the code of the node itself. Like in Substrate, you have the versioning because the runtime is compiled to WebAssembly, and it will compare to the one you are trying to connect to, and it does not match.
Yeah. Okay. Then if you do this properly, it probably will work. Right now, my version of my build version doesn't work, but actually we can. I think it will take too long to run a Docker container in my computer because I need to fetch the images right now. But if you test with the Docker image, probably it will work out of the box. No, it will not.
No,
you don't have
you don't have. It will work
with
the next version. Next week we will deploy a new version with this. So yeah, it will work.
Yeah. And that's also a good news that we have, which is now we can run actually the container not only on AMD CPUs, but we can also run it on ARM. This is the biggest update for today. It was launched during this morning for you, I think. My afternoon.
Yeah.
So basically, these are the efforts for what we've been building on infra. There are still lots of stuff that we can improve. For example, we can already launch instances for the Terraform stuff, but for node operators, there are lots of Ansible scripts that might be useful, and we don't have them at all, and for the moment. So if you are interested in infra, there are lots of stuff that actually you can do with Ansible to facilitate the life of other people. And Ansible it's running on the top terminals, but yeah, this one is going to take a bit. So I'm up to any questions that you might have.
Okay, thank you very much. This is very useful. It will help us a lot to quickly spin up new testnets and for people to join the testnets. very useful. And as Matthias said, we can also try to leverage telemetry services that are provided by Substrate. Like we can configure some Grafana instances, etc., because it already have support of Prometheus metrics and whatnot. So it will be good to investigate and provide some monitoring services from the test.
Yeah, totally. I think monitoring here it's pretty crucial. Yeah. And it's still not that's developed at the moment, but yeah, we sure are going to get there.
Yeah. We can send you some link, but you can start with existing Polkadot Grafana dashboards and whatnot. There are some already existing stuff that you can take to start, and then you can improve them. But yeah.
Yeah, actually, you even in the Madara command, you can specify to have some telemetry.
Yeah, exactly. Yeah.
Totally.
Okay. Okay. With proof of stake, there is a comment in the chat. With proof of stake, you add another layer of monitoring needs. Yes, definitely. Yeah.
So for the answer, I think you can test it on your computer later, because this is going to take a bit of time actually.
Sure. No worries. Okay.
Yeah.
Very cool. Maybe you want to use it when you will deploy the next upgrade for the sequencer of Lambda class. Maybe if you do it, maybe you can try to record your screen so that we can put it as in a folder of Madara as an example. So.
Yeah, totally. So for example, that is one thing that we still don't have in Ansible, and I think it's going to be really useful, is a script for node operators, because most of the node operators only run one node, and right now we are forcing it Ansible to be 3 nodes. So yeah, totally. I actually, when I was testing this with Elias, I checked that would be really useful. Yeah, totally.
Okay.
I agree.
Okay. Awesome. Thank you. Awesome. Thank you very much. Does anyone have any question, comment on anything? Yeah. Okay. So if not, we can stop here. It was a pretty packed agenda. I think it was very useful. So I will share the recording when available. Thank you very much, everyone. It was an amazing community call. See you next week. Bye.
Bye.
Bye.